All right, let's jump right in. You know, we spend a lot of time thinking about our city's big visible infrastructure, the roads, the power grid, but there's this massive hidden system that we almost never consider. What happens after we flush? Yeah, it's not exactly glamorous, but managing our collective waste is honestly one of the most critical and fascinating challenges a modern city faces.
So let's just ask the big question right up front. Every single day, our cities are churning out thousands and thousands of tons of this stuff called sewage sludge. It's got to go somewhere, right? But where? For a long time, we thought we had a pretty simple answer. But that solution is, well, it's starting to fail, creating this quiet crisis pretty much right under our feet.
And that's the perfect lead into part one of our explainer. See, the old school way of dealing with all this sludge is facing what you could call a perfect storm of problems. It's turning a routine task into a real ticking clock for our cities.
Okay, so first we need to get the lingo down. After it's treated, sewage sludge is called biosolids. And because it's packed with nutrients, the traditional go-to solution for decades has been to spread it on farmland as a cheap fertilizer. Seems like a pretty good idea, right? A nice little circle of life, turn waste back into food. But as it turns out, it's just not that simple anymore.
This is where you see all the pressures piling on at once. First, and this is a big one, we're finding toxic forever chemicals. You've probably heard of them as PFAS in the biosolids, and they're contaminating our soil and our waterways. Second, you've got climate change. More extreme rain means fields are often too soaked to spread anything, and it messes up all the trick routes. Then there's simple math. More people means more sludge. And finally, communities are pushing back, hard. They don't want this stuff spread near their homes. You put it all together, and the whole system is at its breaking point.
So if the old way is failing, what's next? This is where the story gets really interesting. It pivots from being about a problem to being about a really cool, high-tech solution. So let's jump into part two and see how some clever engineering is turning this entire challenge on its head.
The answer is a totally new type of building, a regenerative biosolids processing facility. And look, this isn't just some disposal plant. You've got to think of it more like a transformation engine. It's designed from the ground up to be clean, super efficient, and built to last.
So how does this whole thing work? The easiest way to picture it is like a giant, super sophisticated pressure cooker that never stops. First, the wet biosolids come in, and a bunch of the water gets squeezed out. Then comes the real magic. It's heated up to over 800 degrees Celsius in a chamber with almost no oxygen. It's not burning. It's completely transforming the material into two really valuable things, a synthetic gas and a solid carbon-packed material.
That first output is something called syngas. This gas is immediately captured and then used to create all the heat and electricity the plant needs to run itself. It's basically a self-powering loop. This is a total game changer because it massively cuts down on how much energy the facility needs from the grid and, of course, cuts down on the cost. And the second thing it makes is this amazing stuff called biochar. It's basically a very stable, charcoal-like substance that's super rich in carbon. And get this, it locks that carbon away for hundreds of years. This isn't waste anymore, it's a valuable product. You can sell it to improve soil, use it in building materials, you name it. We've literally turned a huge problem into a valuable asset.
But here's the absolute kicker. Remember those nasty forever chemicals? Well, the insane temperatures inside this system, way hotter than just burning something, are specifically designed to completely obliterate them. It shatters the chemical bonds of the PFAS. This single step eliminates the biggest risk that's making the old land spraying method so dangerous.
Now, a facility like this sounds incredible, but you can imagine it's also incredibly complex. So how on earth do you make sure it's built right, that it's safe, and that it's actually going to work day in and day out for decades? That takes us to the blueprint for success.
150. What is this number? Well, that's the number of pages in just one of the engineering design documents for this facility. Just the one covering the basic civil and structural work. It's a number that just screams at you about the incredible level of planning and precision that goes into a project like this.
And that planning covers everything. I mean, everything. The facility is engineered to be resilient against anything you can think of. It's designed to withstand earthquakes, handle extreme winds, and it has advanced fire protection. The floors are even built above the 100-year flood line. The most critical parts are designed to last up to 100 years. This isn't some quick patch. It's a solution for generations.
And you don't just, flip a switch and turn this thing on. Bringing it online is this painstaking 5-step process. You start with what's called cold commissioning, testing every single pump and valve without any actual sludge. Then you slowly move to hot commissioning, heating it up and introducing the real stuff. It's only after they prove, with rigorous testing, that it destroys PFAS and hits all its performance targets, that it gets the final green light for full 24/7 operation.
And the foundation for this entire process is an absolute non-negotiable focus on safety. One of the core principles from the planning documents is this commitment to zero harm. It means that at every single stage from day one of construction to full operation, the #1 priority is the safety of the people, the environment, and the facility itself.
So, we have a problem, an amazing high-tech solution, and a rock-solid plan to make it happen. But what does all of this actually mean? For you, for me, and for the planet? Let's get into our final section and look at the real-world payoff.
This chart really just says it all, doesn't it? When you compare it to spreading on land, this new facility basically eliminates the contaminant risk, slashes transport emissions, and cuts way down on methane. And while the old way is totally at the mercy of the weather, this indoor facility runs reliably, rain or shine, all year long.
And here's the benefit that people in the community will feel almost immediately: a massive drop in heavy truck traffic. Think about it. Instead of hundreds of trucks constantly driving all over the region, most of the material goes to one central spot. That means way less noise, way less air pollution, and safer roads for everyone.
In the end, the impact of a project like this is so much bigger than just waste management. It's about environmental justice for the communities that we're dealing with all that truck traffic. It's about creating good, stable, high-skilled local jobs. It's about a city stepping up and showing real leadership and sustainability. And it is, without a doubt, real climate action, cutting emissions and locking carbon away in that biochar.
Which leaves us with one final, big question to think about. We started with this hidden, kind of gross problem that most of us would rather just ignore. But by applying some really smart engineering and a whole new way of thinking, we ended up with a blueprint for the future. And it makes you wonder, what other waste that we overlook every day could be turned into the next valuable resource that completely redefines our cities?